Hello everyone, this is Jiacheng I'm recording this for EC6303 Homework 10. And let's see the second question. We need to collect all the definition of the stochastic process. And actually, we need to define the WSS, independent increment, Markov, normal, strict sense, strict SSS, and white noise, mean ergodic, and we don't need to care about this part. So let's look at my solution for this problem. So the first thing is that how can we define the stochastic process? Actually, y stand stationary, and we know that y stand stationary is only constant, and only correlation need to be the function of time difference. So y stationary use the mean and autocorrelation, and autocorrelation function is just basically a T1 minus T2 part, T2 equal T1 equal T2 part, and this is the R1, T1, T2 is the average power of the signal at T1, and this is, we can treat it as a y stationary process. Oops. And with very simple description. And second one is the independent increment process. The xt minus t2 equals to equals to means that the xt1 minus t2 and xt3 minus t4 are non-overlapping intervals, are independent. And Poisson, we know that Poisson random walk, Wigner process, and independent increment process. And the third one is the Markov. As we have just mentioned, that the increment may have the potential of the Markov process, so it has no influence on the future when the present is known. So this is, and in many cases in our world, lots of processes have the Markov property, and we know that so far Poisson impulse, semi, telegraph, random walk, and Wigner, all of them are Markov process. And so we know that it's very normal. And third one is very important, is about the normal and the Gaussian, and we know the definition of this one. It's just all of them are like jointly normal. So this is the definition, and we know that the statistic of normal process is determined in the term of eta t and rt1 t2. Eta t is a function of t and classify normal process as a property of stochastic process. It's a very basic process. As like this process is like the condition is very hard. That's treat like the Wigner is like a very special case for this like a larger class of stochastic process. And the fifth one is also very important, is the strict sense stationary, which is very hard to satisfy, because we need to satisfy this property. Is very hard. It's like very strict. We know we need to, for all the t plus epsilon is equal to the fx. And the sixth one is about the white noise. White noise, the thing is that we need to know that this is equal to 0. And like we say, the white noise has like a 0 mean, and the correlation is just like this mentioned here. It's just a delta function, and we use the eta t here to represent how can we define the white noise. So white noise is like a special case of the Wigner. And the seventh one is about the stochastic process. It's like a mean, to define the mean ergodic. So the only thing we need to focus on is that if this one is equal to, if the xt when we calculate the minus t to t integral is equal to expectation of xt in mean square sense, it's one or kind of consistency. There are others. In property with property 1, mean square error is just we defined only. And the eighth one we can talk about a little bit is just ext when xs is equal to x1 is equal to x1. So this condition means equal the condition. This is true for random work and the Wigner. And that's all for this problem. Thank you all for listening.